point. So what we're looking at today is system variables. So we learned about system variables, or we learned about variables generally last week. And so just as a quick review, variables are just basically keywords that we make up to reference pieces of data that we use in our program. So variables can save different parts of data, like the X position of your drawing, the string of text that you want to display, and then we can update variables to change them over time. And so we've actually seen a couple examples of system variables already in some of the lessons that we've been doing, just to kind of use as examples. But we're going to go into a little bit more depth with them now and talk about how we can use them to create interactions. And before we do that, we're just going to review how setup and draw work. We've talked about this a bunch already, but we just want to review this so we can understand what's happening when we create an interactive project. So as an example, let's go over here to our example. I'm going to make a comment and just do a little intro comment as usual. So this is our system variables example. And I'll just put the date. It's the 28th. Okay. So just to review setup and draw, setup runs once when our program starts, and it sets some basic values. It creates a canvas, it creates the width and the height of the canvas, and we'll use it in future lessons as our programs have more moving parts and do more things. We'll use it to set up other properties that we just need to set up once and then, not have to worry about. Draw is running all the time. It's running once, every frame, and it's painting whatever we ask the program to paint onto our canvas. And so the reason we're able to do things like animation and interactive art is because we have this draw function. Is there sorry, I hear like a weird noise.
That's my laptop fan.
Oh, right, okay. No worries. Okay, so the way that we can kind of see how that works, if I delete my draw function, or I'm just gonna select this area and just hit command ? And comment it out. So I can draw stuff in my setup function. And so I can have like a little ellipse there. I can even draw a background in here. And let's make this ellipse a little bit bigger, just as an example. Okay, but as soon as I start drawing, that's gonna go away. So if I bring my draw function back, I'm covering up that ellipse with the draw function. So if you're just gonna do one design and you don't need it to be interactive or do anything else, you can actually just use setup. You can do everything you would want to in setup. And most of the stuff that we've done so far, you could actually just have used the setup function. Some of you guys have started to add some interactivity and animation, so you would need the draw function for that. But most of the projects that we've done up until this point in the semester have just been a static image that we've generated through code. And so, we haven't actually really been taking advantage of the fact that the draw function is repainting our drawing over and over again because it just looks the same. But what we can do, the thing that we can do with, our draw function that we can't do with just a static painting is to move things around, add animation and interaction. So if I put this ellipse in here instead, it's going to look the same until we start to add some variation. So that's where our variables come into play, as we've talked about. If I just have a number here, this is called hard-coded, so this doesn't move. So this is hard-coded. All of these numbers are just numbers. They can't change. But if we use variables, so I'll just put variables here. And you guys have already seen this. This is one of our system variables. If I say ellipse at mouse X, mouse Y, now we can have this motion. We can have interaction. So I can move the mouse and it changes using the value of the mouse to move the circle. So there's certain things that are kind of like conventions with this. This is why like we have the X position and the Y position, and then we map that to mouse X and mouse Y. But that's not the only way that we can do interaction. We can also do things with color and size and different things like that. And so we'll start to look at how we can do things like that. And just as another reminder, so this is what's really happening if I take out that background. Notice what's happening is we see all these circles in the background because we're just painting this drawing over and over again. And as I move that circle, we're painting it in different places. The reason it looks like it's moving around on the screen is because we're covering up the previous paintings. And so we create this illusion that there's this moving thing on the screen.
What makes it print itself over and over again?
So that's when I take the background out.
Oh.
So when I put the background back in, we just see one circle because we're covering up all the previous circles. But when I take the background out, I'm using that as a way to demonstrate what the program is actually doing. It's painting the circle in all of these different places as we give it different parameters. So as the number, the mouse, as that moves, the number that's going into that X parameter is changing. And we're painting it in different places. It just looks like it's moving because we're covering up each previous painting.
So basically what you're saying is that every time you move the mouse, it prints that ellipse over. It prints that ellipse again.
Well, actually, it's doing it regardless of whether I move the mouse or not. But when I move the mouse, the circle changes position. So it's painting all the time. Moving the mouse is separate from that. Let's do a quick example of that. So if I want to know actually how many frames it's drawn, I can actually show the frame count. So let's put this down here. I'll say frame count, or I'll say text, and I'll put in the frame count. This is the number of frames that have happened since the beginning of the program. So let's put this up in the right corner, and you can see that number is just going up as the program goes. Let's make it a little bit bigger. So you can see that number is getting higher and higher and higher, and that's because that's how many frames we've drawn since the beginning of the program. So it's drawing around 60 frames per second. So each second that passes, it's drawing 60 times. And we can slow it down. So if I say something like frame rate is 2, now we'll see the number of times it's being drawn is much lower. It's only drawing 2 frames per second. So every half second, it draws another frame. And so you can see that we're still updating our drawing, but where we draw the circle is kind of choppy. We don't see all of the smooth motion in between. So if you play video games, you've probably thought about the frame rate of the video game, the FPS of the video game. And if you're playing a video game and your computer is not fast enough, the frame rate starts to drop and it starts to look choppy and it slows down and stuff like that. So that's kind of what's happening there. And that's basically what every computer that's doing anything is doing. Any program, whether it's Chrome or Photoshop or Microsoft Word, it's painting all of this information onto the screen over and over and over again. And that way, when we update things, if I add a new character into the paragraph that I'm typing, it paints the screen again with that new characters. That's why computers are interactive. That's why we can type on our keyboard and move our mouse, and we can see the result of what's happening change on the computer screen. So this is very basic, but this is literally the basis for everything that happens on our computer that makes it able to do what it does. Okay, so if I increase the frame rate to like 12 or something like that, now it's going to move a little bit faster, but we still see this kind of choppiness. So like imagine you were trying to write an essay on Microsoft Word, but every time you typed, it didn't immediately add the character. It waited like, half a second to add the character. You would notice that it's not working correctly. So if we take this out, we'll get the normal frame rate, which is about 60 frames per second. I don't know actually I would guess that that's what it's going for, but I'm not 100% sure. It could be trying to go faster. So anyway, that's what's happening when we're using the draw function, and that's why we're able to do interaction and animation with our program, rather than just creating static images like we would do in Photoshop or Illustrator. Okay. So let's continue a little bit. And so we're going to do a quick example, and then we'll get into some more system variables. So right now I'm moving the ellipse based on the mouse position. And even though this is interactive, this is actually easier to do than an animation because it's just updating to wherever the mouse is. When we start to do animation in a couple weeks, we'll realize that we have to add other variables that can keep track of where our ellipse is. And so an example of that is I might have a variable x, and I might set that equal to 0. And I might draw my ellipse at x instead of mouse x. And actually, let's leave this here. I'm just going to comment this out and do this. Okay, so right now x isn't changing, so our circle stays in the same place. But what I can do is I can say x plus plus. This is just a shorthand for adding 1 to x, and it's going to do this every single frame. This is sort of like saying x equals x plus 1. So whatever the value of x is, add 1 to that, and then we keep going. And now we get this little animation. So the circle moves across the screen because x is updating every frame. And eventually it's going to go outside of the frame, and it's not going to come back. So in a couple weeks, we'll learn more about animation and how to control those values. But for now, that's pretty, we can create this animation by basically using this variable and changing the number that we see there. And if I want to, go faster, I can add more to it. I could say go 10 frames or, 100 frames every time we draw. And so all that's doing is it's adding 1 to the number x as we go. One thing that I want to point out, though, before we get into more stuff, is notice that I put x here. So what would happen, I'm going to show you what would happen. If we put x right here, you'll see what's going to happen is that it doesn't go anywhere, right? And this has to do with our program scope. So our function draw, we know it's getting called every frame, so 60 frames per second. And when we put x right here, basically we're resetting the value of x every time we draw. So the ellipse isn't moving because x isn't actually changing. Even though we change x here, we go back to the beginning of the draw function each frame. We draw the background again, we draw our circle again, and then we set x to a new thing. So we can do this, but we're not going to get the result that we want. So that is the reason why I declared x here. Because I can set the value of x here, and then I can update it here, but x exists outside of the draw function. So the draw function is just this kind of like thing that does one thing. It paints the screen. But it can't really do anything else because it doesn't have access to other parts of the program. So I take x out of the draw function, and so x can exist on its own, and then the draw function can change x, but x still exists. It's like it still exists basically when the draw function happens again. So it's kind of like, when the draw function is done, it's almost like it goes to sleep, and anything that it was created in the draw function, when it finishes, just disappears. It doesn't exist anymore. So by putting x up here, we're changing the x scope. So we're putting this in the global scope. So when programmers refer to the scope, they're talking about where something exists. So something can exist inside of a function, like setup or draw, or if it's not inside of a function, it's in the global scope. So the global scope is like the general area of the program. So you could imagine this is kind of like, the world has all this stuff in it, and then we have functions that kind of like encapsulate, certain things that they do. But if we want this x to exist and be able to change, we need to put it into the global scope. So the reason mouse X and mouse Y works is that they're already in the global scope. P5 creates them for us. And so P5 is actually adding a bunch of code in here that before we had libraries like this, we would have just written ourselves. But it's convenient. They make this thing called mouse X, and they say, a lot of people want to know where the mouse is. So we're just going to make this thing called mouse X. We're going to make this thing called mouse Y, and we're going to update it for them. So just like setup and draw, P5 just created it for us, and so we don't have to do it ourselves. So that's convenient, and it adds it into the global scope, so our draw function can access mouse X and mouse Y and use it, to update our sketch. One thing that you'll notice is if I try to console.log mouse X, mouse Y in the global scope, I'm actually going to get an error. Mouse X doesn't exist. So one of the tricky things about P5 is they create mouse X and mouse Y, but they only let you access them inside of the P5 functions. There's a lot of reasons for why they do that, mostly because it could mess up other programs that are happening on the website. But all the P5 stuff, like mouse X and mouse Y, and some of the other system variables we're going to look at in a second, like this one I used before, the frame count, they only exist inside of our P5 functions. So you can't say something like X equals mouse X up here, because mouse X doesn't exist in the global scope. Okay. So let's set X back to 0, and let's look at some of our other system variables. Okay. So So when we create a canvas, we put the two numbers in there, and P5 creates two system variables for us to capture those numbers so we can use them later, the width and the height. And this is very useful because let's imagine that we wanted our circle to take up the whole canvas. I can put in here for the ellipse, let's put this down here. Okay, so let's say we have another ellipse, and I'm just gonna put it in the middle again. Okay, but let's say I want the ellipse to take up the whole canvas. I can just put width right here. So width is something that gets created by P5 when we create the canvas. Whatever number we put first, it says that's gonna be the width, and then it saves that in this variable called width. And so now I can just reference the width of the canvas just by using that variable. And P5 is always going to do that. So if I change this number, it's going to change the size of the circle. Notice that it didn't move over. So we're going to look at another thing that we can do. So if I change the canvas smaller and smaller, notice that the circle is changing to the size of the canvas. Yeah. So that the canvas would change sizes? Yeah. You technically can, but your browser will probably freak out and do weird stuff. You really don't want to resize the canvas. You could so you might want to do it in some cases, like if you go from like a smaller canvas to like a full screen view, then you might want to resize it, but you wouldn't want it to be like sizing every frame or something like that, because it's too much. Creating the canvas itself, it happens relatively fast, but compared to painting, it takes a long time relative to the computer, so it wouldn't really be able to do that very well. So there are instances where you do that, but probably not in this context. But I am going to show you something you can do that's similar to that in a second. Okay, so let's set it back to 400 for a second. So I also have the height, so if I change this to height, it's going to look the same. But now when I stretch it out, it's going to stay the same height. Okay, so that takes the height of the canvas, and we're assigning that to the circle. And then the other thing we can do is we can use that to center our circle. So right now when I change the size, if I change this to 600, the canvas gets bigger and the circle gets bigger, but the circle stays in one place. And the reason for that is this X is hard-coded. It's just 200. It's always going to be 200, regardless of what size the canvas is. But if I want the X to move, I already have a variable for X, so I'm just going to redefine it here. Or actually, no, that's not going to work. Okay, let's just make another X. So I'm just going to say variable, I'll just call this ellipse, or I'll call this center X, because we want to center the ellipse. So if I want to know what the center of the canvas is, I just take the width of the canvas and I divide it by 2. So it's very easy. So I can say width divided by 2. And now I put that center X as my value here. And it's going to move that circle to the center of the canvas no matter where, or no matter how big the canvas size is. Okay, so now if I start to vary the height, I'm going to run into that same problem where the circle doesn't update to the height. So we can do the same thing with our y. So we can say variable center y is height over 2. Okay, so now the circle is always going to be centered and the same size of the canvas. This, there's lots of having a circle that's the same size as the canvas isn't necessarily the most important use case for this, but you can imagine doing any type of design where you want things to be centered or aligned or in a grid. You can use the width and height values to set that up. Another couple of variables that we have, we can set the canvas to be the size of our window. So whatever the window size in the browser is, we can say window width and window height. And so it's going to match. Right now it's just in this little preview window. But you'll see if I change the size of the preview window, it's going to stretch to fit that. So it can get that from the browser. That's actually pretty easy. Basically, if we open the console, there's this thing called the window that tells you information about the browser window. And what it's doing is it's just saying what's window.inner width. And it tells you the answer. So that's just some basic JavaScript, but P5 just turns that into window width for us, just a little bit easier to reference. And you don't have to use them together. Like I could have window width for the width, but I could just have 200 for the height. That's fine. I can mix those values. Okay. Excuse me. Any questions so far? Okay, so let's keep going. Okay. Okay. Just for completion's sake, let's do a rectangle too. Okay, so if I want to draw a rectangle like that, there's a big square. So remember that the rectangle coordinate system is a little bit different. It draws from the top left corner. You can actually change that. You can change the rect mode to center, and then it'll draw from the center. But let's just use the top left corner for now. So if I want it to fill the window, I'm not going to go to the center because it's not a centered shape. I'm going to go to 0, 0. So now, for the rectangle to fill the window, I just say width and height. So it's actually a little bit easier than our circle. So that's, this is basically like a background now. This is covering everything up, so I'm going to take it out. But yeah, we can do the same thing with the rectangle. You could do it with a triangle as well. If you wanted a triangle that covers your, half your screen, you could say triangle. And this is where, you'll see this is where programming starts to get a lot easier, because instead of doing math, you're actually just using variables. So if I want a triangle that covers half the screen, I know that I would just say, okay, I want to start at the top left, so that's 0, 0, and I want to go all the way to the right side of the canvas, but stay at the top. So I would go over to width, and I would have 0 on y, because I'm not going down. And then if I want to go back to the beginning, I would go back to x is 0, but now y is height. So I'd say 0 and height, and now I've got a triangle that's covering half the canvas. And the nice thing about this, again, is if I change the size, it just updates automatically. So I don't have to do math. I don't have to add and subtract and divide, as long as I understand what these values represent. And if I want to swap the thing, I can just change this to width for the x. So now it's going to that side instead of the other side. So once you start to kind of learn the programming rules, you actually are going to end up doing less like adding numbers together and more just using the variables and figuring out where you want things to go. So let's hide that for a second. Okay, so the variables that we just looked at, width and height, those are static variables. Once we create the canvas, those numbers never change unless we change the canvas size. Mouse X and mouse Y are dynamic system variables, so they're always changing. And we've already seen examples of that. So we can see that again. So if I draw, let's say, dynamic variables. So let's draw a little ellipse at mouse X, mouse Y, and I'll just make it 20 pixels. So you can see there's the mouse, and we can move it around on the screen. And it's just updating. So this is what I was talking about with the convention. The order matters here. So there's no reason why I can't put mouse Y in for both of these. Mouse Y is just a number. It's just going to be confusing. So now you can see when I move the mouse down, the circle also goes to the right. I could even just put mouse Y, just for where the circle is. So this is counterintuitive, but they're just numbers. So the numbers, even though it's called mouse X, and typically we would want to map it to mouse X, it's just a number, and we can put the number wherever we want. So when I'm moving this around, it's gonna, do whatever. It's changing the X position of the circle, even though you can see my mouse is moving up and down. And when I move left to right, as long as I do it pretty evenly and don't also move up and down, which is kind of hard to do, you see that the circle stays in the same place. So that's, we do have these conventions. That's why we have the order of things usually matches. So we tend to see things as X, Y, width, height. But, those things can change. So let's change this back to mouse X, mouse Y for a second. And then let's draw a line. So I'm going to draw a line from 0, 0 to mouse X, mouse Y. And we'll see that, one side of this line is stuck because it's hard-coded. It never changes. That's the 0, 0. And one side of the line moves with my circle because we're drawing to mouse X, mouse Y. So the circle moves with the mouse because it just has a position and a size. But remember, our line has 2 points. And so if one of those points is hard-coded, it's not gonna move around with the X. If I change this, there's another variable I have called pmouse. So if I change this to pmouse X, pmouse Y, this stands for previous. And so you can see it's drawing this little line between the X position, the last position I was in, and the current position. So if I move really fast, the line is longer. If I move slowly, you barely see the line at all because that difference is very small. And that's really useful for if you're creating, if you're making a drawing application like Photoshop, you would need to be able to draw between the brush strokes. Okay, so we have some dynamic system variables. We also have the frame count. I already put this up there, but the frame count is just the number of frames that have happened since the animation started. You can use that for animation and stuff, but generally we just make our own variables. But you can see that frame count is still running up there. And I think that's it. So we can do a lot of different stuff with these variables. So I'll show you guys an example, and then I'll let you guys just play around with it. And in the second part of class, I'm going to go into a little bit more detail about some slightly more complicated math things that we can do with these values to make our interactions a little bit more interesting. But so another thing that I can do here, I can set the fill. So if I set the fill to 0, 0, 0, you know, it's just black. We have 0 on every channel, red, green, and blue, so we just get black. And I can make that dynamic. I can set mouse X, and so now we get red. But I can also set it to things like, you know, width over 2, and so we're going to get this red value. You know, we can set it to those different numbers and get things based on that. So we'll look at ways to make that a little bit more interesting in the second part of class. But for now, you can see I can make it more or less red by moving the mouse. I can put mouse Y into the green channel, and now I get this kind of distribution of colors. I can also do things with the size, so I could say mouse X for the, oh, that's the fill, never mind. Where's my circle? Where's my big circle? Oh, it's up here. Let's just draw another circle. So I'll say ellipse, 200, 200, and width. Or no, mouse X. Okay, so now you can see this circle that's tied to mouse X. As X gets bigger, the circle gets bigger. So the X number is just a value, and the circle is just going to get bigger based on that value. If X goes to 0, the circle will be 0, so you can also offset this. So I could say, like, I don't want it to be less than 100, so I could just say mouse X plus 100. And so now it's never going to be less than 100, but, you know, it'll get bigger as we add X to it. And we're going to look at more sophisticated ways to do that, but this is just an example of how we can use some simple math to do something like that. Okay. So for now, I want you guys to just experiment with this stuff and just see how you can, you know, use this in a design. And then in the second part of class, we'll look at a few more techniques that we can use. But for this assignment, the idea is just to create an interactive design. And so this just means that the user can change something about the design as they're looking at it. It doesn't have to be anything in particular. It can be the position of something, it can be the color, it can be the size. But there's two things that make this a little bit different. So one thing is that we want to basically tell the user what to do. With interactive art in particular, we can't just assume that people know that something is interactive. So if you have like an interactive work of art in a gallery and it's on a screen, people aren't going to know, oh, that's something I can interact with. They might think it's just a static, you know, image or whatever. So we have to give some instructions. I'll go over how to do that in the second part of class. And then the other thing is just thinking about what are we representing. So we want to make something interesting. It's easy to make some colors change or make some shapes move, but if they don't represent some idea, Miriam actually had a good example of this in her homework the other day. Let's take a look at that. With the moving self-portrait. So this was a good example of, you know, the interaction maps to some, like, you know, thing that we recognize. Like, we're sort of pulling back this sun and revealing the moon. We can also move the sun up and down, which makes sense because the sun rises and sets. So, you know, it's a very simple interaction, but it has this connection to something that has a symbolic meaning that we understand. So we want to make sure when we're making interactive art that we're not just saying, look at these cool colors, but that we're communicating a recognizable idea as well. Okay. So I'm going to stop there for now, and we'll have some workshop time. Let me know if you guys have any questions, and then we'll do a little bit more at 4 o'clock.